Good evening, students. Welcome to Unacademy, the largest online e-learning platform. Good evening, Srinivas. Good evening, Swarnasri. Welcome to Circuit Theory Crash Course. Today we'll be dealing with Lecture 4, Super Mesh and Super Node Analysis. So I request you all to share, like my session. So the topics that we'll be discussing today are circuit theory. In circuit theory, super mesh and super node analysis. In circuit theory, we'll be discussing super mesh and super node analysis. Now, before that, let me tell you, I'm Vai Shravan Kumar, having 7+ years of teaching experience, mentored more than 5K students for GATE and engineering services, and cracked GATE. And let me tell you the Unacademy Learning app installation procedure. In Google Play Store, type Unacademy Learning app. You'll get this Unacademy Learning app, and you have to click on install. Then if you are opting for GATE and engineering services, you can click on this. If you are opting for IIT JAE, you can click on this and click on this plus, and you'll get subscription in step 5. And you have both plus and iconic subscriptions. In iconic subscription, you'll get a dedicated mentor for your preparation, and you can also use my code as YSK10 to get maximum discount and click on proceed to pay. When you click on proceed to pay, you'll have different payment platforms like debit card, credit card, EMI, UPI, wallets, net banking. Using any of these payment platforms, you can get subscription to Unacademy. Now today's topics are super mesh and super node analysis. Today's topics are super mesh and super node analysis. Raju, good evening. Hi, sir. Good evening. Good evening, Raju. So the today's takeaways are super mesh and super node analysis. Super mesh and super node analysis. So now let us look at before that yesterday in previous session we have discussed about mesh analysis and nodal analysis. Mesh analysis and the other one was nodal analysis. So we'll discuss this mesh analysis, nodal analysis yesterday, and we have also taken up some problem. Today we'll be discussing super mesh and super node analysis. Today we'll be discussing super mesh and super node analysis. So let us see one problem on this mesh and nodal analysis. Then we'll move ahead with the super mesh and super node analysis. Let me take a question for you. One of the previously asked university questions. Let us consider a question. Let us say the question is something like this: current in find current in find current in or through 10 ohm resistor. Find current through 10 ohm resistor. Augustus, good evening, sir. Good evening, Augustus. Yes, sir, good evening. So 10 ohm resistor in given network, in the given network. So this is the question, let us say, and there is a circuit that is given something like this. Let us consider this circuit. This is the circuit. There is a resistor over here, and there is another resistor, and there is one more resistor with a resistor here. And this value of voltage source is 2 volts, and this is 1 ohm. This is 1 ohm, 2 volts. This is 10 ohms, and this is 5 ohms, and this is 15 ohms. Now let us solve. Let the question be something like using mesh analysis. Using mesh analysis. Let us say this is a question. Now, if you look at this, the solution of this, what we have to do first, we have to identify how many number of meshes are there. How many number of meshes are there? Two. So, how many number of equations you get? What is the number of equations that you get? You will get two equations. And we are asked to find current in 10 ohm resistor, current through 10 ohm resistor. This is the value. Now, let us consider using mesh analysis. You can take this as I1 in this direction, this as I2. Let us take two currents, I1 and I2. Now consider this as mesh 1 and this as mesh 2. Now apply KVL to loop 1. What we are doing? We are applying KVL to first loop. We are applying KVL to the loop 1. We are applying KVL to loop 1. Good evening, Karthik. Hi, sir. Hi, Karthik. So this is applying KVL to loop 1. Let us consider what is the loop 1 circuit. So this is the loop 1. You have a resistor, a voltage source, again a resistor, and this is a closed path. This is the loop, right? So this is the loop. In this you have this current as I1 in this direction, which we have taken. You can take any direction. I have taken in the clockwise direction. This has 1 ohm, this has 10 ohm. The current that is flowing in 1 ohm is only I1, whereas the current flowing in this is, there is another current I2 is also flowing through this 10 ohm resistor. This is I2. Now if you look at this, we can write in this KVL, let us call this voltage as V1 and this voltage as V10. So algebraic sum of all the voltages 2 V1 V10 is equal to 0. These three are the voltages. Just write those voltages, and I'll take this voltage source as positive, so these will be negative. So 2 minus V1 minus V10 is equal to 0, or V1 plus V10 is equal to 2. V1 and V2 I have taken it to the other side. Now this is applying KVL. Now apply Ohm's law. What is 1 ohm resistor? If you take up the 1 ohm resistor, the voltage across this is V1. What is the current that is flowing? It is I1. So what is voltage? Voltage is V1 is equal to I1 into 1. V1 is equal to I1 into 1. I1 into 1. So V1 is equal to I1 into 1 plus what is V10? In V10 is a voltage across 10 ohm resistor. V10 is the voltage across 10 ohm resistor. So in this, the current that is flowing is I1 is flowing in this direction clockwise, and I2 is flowing in the, sorry, this is clockwise direction, and I2 is flowing in this anti-clockwise direction. This is also in the clockwise direction. Both we have taken in the clockwise direction. So you can say this is also in clockwise, this is also in clockwise. One is going down like this, other one is coming up like this, you can say. So this is I1 minus I2. So V10 is equal to 10 into I1 minus I2. So this is 10 into I1 minus I2 is equal to 2. This is one equation. So you can simplify this as I1 plus 10 I1 minus 10 I2 is equal to 2. So this is 11 I1 minus 10 I2 is equal to 2. This is about the loop 1. Now let us consider the loop 2. So this is one equation. Next, apply KVL to loop 2. Now what is the loop 2 that you need to draw? You have three resistors, 10, 5 and 15. You don't have any source, 10, 5 and 15. These are the three resistors that you have. This is 10 ohms, 5 ohms and 15 ohms. Let us call this voltage as V15, the voltage across this as V5 and the voltage across this as V10. Now the currents that are flowing through this is, one is I1 current that we have taken in this direction. I1 current that we have taken in this direction in 10 ohms, and there is another current I2 that is flowing like this. I have taken the current directions. Vishwajam, good evening. Welcome to Circuit Theory Crash Course. Now if you apply what are the different voltages that you have? One is V10, other one is V5, other one is V15 is equal to 0. All being drops, I'll take them as negative. So it is minus V10 minus V5 minus V15 is equal to 0, or you can take V10 plus V5 plus V15 is equal to 0. Now you need to write V5, V15, V10. What is the voltage? If you take this resistor of 5 ohms, what is V5? It is a current. The current that is flowing through this is I2. So V5 is equal to I2 into 5. Similarly, what is V15? What is V15 is equal to current that is flowing through this is I2. So 15 I2. Now what is V10? The same that we have got here, but V10 is the resist. V10 is the value of the voltage across 10 ohm resistor, which is 10 into I2 minus I1. So this is 10 into I2 minus I1 plus I2 into 5 plus 15 I2 is equal to 0. If you consider this, it is minus 10 I1 plus 10 I2, 5 I2, 15 I2, 30 I2. So 30 I2 is equal to 0. This is the second equation. Call this as 2 and this as 1. What is this equation? 11 I1 minus 10 I2 is equal to 2. 11 I1 minus 10 I2 is equal to 2. From this second equation, this is the first equation. From this second equation, you can write 30 I2 is equal to 10 I1, or I1 is equal to, you can cancel this, 10 3s are 3 I2. So substitute I1 is equal to 3 I2 in this equation. 11 I1 minus 10 I2 is equal to 2. 11 I1 minus 10 I2 is equal to 2 in this. Anup, namaste sir. Good evening, Anup. Sham Sai, good evening. Now substitute I1 is equal to what we got? 3I2. So 3I2, if you substitute this in this equation, so 11 into 3I2 minus 10 into I2 is equal to 2. 33 I2 minus 10 I2 is equal to 2. So 23 I2 is equal to 2. Therefore I2 is equal to 2 by 23 amperes. Now let us take I1. What is I1? You need to find I1. I1 is 3 times of I2. I1 is 3 times of I2. I1 is equal to 3 I2. I1 is equal to I1 is equal to 3 I2. So I1 is equal to 3 into 2 by 23 amperes. So I1 is equal to 6 by 23 amperes. What is the question that is asked for us? The question is find current in 10 ohm resistor. What is the current that is flowing in 10 ohm resistor? It is I1 minus I2, or I2 minus I1. So it is I1 minus I2. Current in 10 ohm resistor is I1 minus I2. What is I1? 6 by 23 minus 2 by 23 is equal to 4 by 23 amperes. This is how you'll solve the question. This is one problem on mesh analysis. Now let us take, there is something like question. Good evening, Soumya. Now let us take the same circuit. Let us consider this same circuit. I am redrawing this circuit, and if there is a current source here in this case, what will happen? So that becomes super mesh analysis. I'll just tell you with a question. What is this is, if a current source is common to two loops, we consider it as a super mesh. What does this mean is, I'll just give you one example here and we'll take up a problem in the next slide. Let us say this is the question. Let's call this voltage as 5 volts, 2 ohms, 1 ohm, 6 ohms and 3 amperes. Now if you try to apply KVL to this, because KVL says that algebraic sum of all the voltages is equal to 0, but when you write this is one voltage and if you write 2 into I1, this is another voltage, but you have a current source here, so you cannot write the voltage term. So what we do is, whenever such current source is common to two loops, we will consider these two loops combinedly as one super mesh. So this becomes a super mesh and we will apply KVL to this super mesh. That becomes one equation, and write current equations to this current source. That becomes the other equation. Then we try to solve them. So let us take a question. The same question that we have taken. Find current in 10 ohm resistor through, using mesh analysis in given circuit. And the circuit is the same that we have considered just now. There is a resistor, a voltage source, again a resistor, and then you have a resistor with a current source here. In the previous case I have not taken this current source. Then you have a resistor here like this. See here, if you can see the current source is common to both the loops. If you take these values, this is 2 volts, 1 ohm, 10 ohms, 5 ohms, 4 ampere, 15 ohms. This is given. Now you need to solve this by using mesh analysis. Now let us consider this mesh analysis. Now if you identify how many number of meshes are there, you have 3. So how many equations you need? Number of equations is equal to 3. Now if you observe, number of equations is equal to 3. Now let us take the loop currents. Let us consider this loop current as I1, this loop current as I2, and this loop current as I3. Alright, so we have considered 3 loop currents. But when you observe this in this loop, and in second, let us say this is loop 1, 2 and 3. Now if you observe these two, this is in, if you are writing voltages, it is 10 into I2 is voltage, 5 into I2 is a voltage, 4 is a current. So you cannot write that equation. So instead what we will do is, we will consider this as a we will consider this whole thing as a single mesh. We'll consider this as a single mesh. This is considered as a super mesh. Now this becomes a super mesh. This becomes a super mesh. So what we'll do is, we'll write that equation. There is a current source with I2 in this direction and I3 in this direction that we have considered, and this value is 4 amperes. Now because I3 is in this direction, we can write I3 minus I2. I3 is in the direction of current source, I2 is opposite to the direction of current source. You need to write I3 minus I2 is equal to 4 amperes. This is one equation. Now let us apply KVL to this first loop and 2 and 3 as a super mesh combinedly. Now if you write to loop Shivakumar, good evening sir, good evening Shivakumar. So apply KVL to loop 1. Now if you apply KVL to loop 1, when you apply KVL to loop 1, this is the resistor, there is an resistor. Let us consider this is 10 ohms, so voltage across this be V10 and this has 1 ohm, so voltage across this be V1, because the current is in this direction we have taken plus minus. This has plus minus and this has plus minus, this is plus 2. Now what can we write? 2 is equal to V10 plus V1, voltage rise is equal to voltage drop. Then you can write 2 is equal to, what is V10? It is 10 into, what is the current that is flowing? I1 is in this direction, I2 is in upward direction, I1 is in downward direction, right? I1 minus I2 plus what is V1? V1 is the voltage across this. So 1 into I1. So this is I1. So you can write this equation as 10 I1 plus 1 I1, 11 I1 minus 10 I2 is equal to 2. The same equation. Hope you are able to understand this. 11 I1 plus 11 I1 minus 10 I2 is equal to 2. 11 I1 plus 10 I2 minus 10 I2 is equal to 2. This is one equation. Hope you are able to understand this. We have done in the same previous class. Now let us look at the super mesh. Let me take this circuit to the next slide and I'll write the super mesh equation. What is the super mesh equation? Directly you can write is, in this super mesh you need to we can draw it super mesh separately. So this is the super mesh. In this is 10 ohms, this is 5 ohms, this is 15 ohms, and current here is I3. Assuming that there is no current source here, we'll draw super mesh. This is I2. Now you can write the equation. How do you write that equation? You need to write this equation. Let us consider this voltage. Current is in this direction, so plus minus this is V10. This is plus minus current in this direction. This is V5. Current in this direction plus minus V15. So you can write V10 plus V5 plus V15 is equal to 0. All are drops, so I have taken negative as the common. Then what is V10? V10 is the voltage across 10 ohm in which there are two currents. One is I1 current that is flowing like this and I2 current that is flowing in the upward direction. So 10 into I2 minus I1 plus 5 into I2. 5 is in the second loop if you observe. So plus V15 is 15 I3 is equal to 0. You can simplify that and get minus 10 I1 plus 10 I2, 5 I2 is 15 I2 plus 15 I3 is equal to 0. So you got three equations. This is the first equation. I3 minus I2 is equal to 4. The second equation was this equation. 11 I1 minus 10 I2 is equal to 2. 11 I1 minus 10 I2 is equal to 2. So these are the three equations you have got. Using these three equations and simplifying them, now we'll use these three equations and when you solve them, by solving these equations, it is very simple to solve these equations. You will get what is I1 is equal to minus 2.35 amperes, I2 is equal to minus 2.78 amperes and I3 is equal to 1.22 amperes. Now what is the question that is asked? You just solve this equation. So by solving, you would get these values of currents, and the question asked is find I in 10 ohm resistor. I in 10 ohm resistor. Therefore, current in 10 ohm resistor is equal to, what is the current in 10 ohm resistor? If you observe, it is I1 minus I2, or difference of I2 and I1. So it is I1 minus I2. I1 is minus 2.35 minus of minus 2.78 will give you 0.43 amperes. So this is the current that is flowing in 10 ohm resistor. Hope this is clear for you all. So this is a super mesh. So this is a super mesh. This becomes a super mesh. This is a super mesh if you observe. So this was, imagining that you don't have any current source here, we'll consider this and write these equations. Okay. So this is about super mesh analysis. This is about super mesh analysis. Clear? Now let us consider. So this is the current that was asked. What is that? The current through this 10, that is I. So we have found that current as 0.43 amperes. Now let us take up a problem on nodal analysis, and then we will see the super node analysis as well. We will see the super node analysis also. So let us consider first what we have done in the last class as nodal analysis, which is the combination of KCL and Ohm's law. I'm sorry, KCL and Ohm's law. So let us consider a question and solve it by using nodal analysis. Then I'll show you what is super node technique. So let us take a question. I'll just take a question from one of the textbooks of Ravish R. Singh. There is a question like this. First I'll draw the circuit. So this is the circuit. So this is the given circuit, and the values are given are, I'll just write them: 1 ampere, this is 1 ohm, this is 2 ohms, this is also 2 ohms, this is 1 ohm, and let us say this is 2 amperes. Now the question asked is find the voltage at nodes 1 and 2. This is already given as node 1 and this as node 2 and given as voltages V1 and V2. The question is find V1 and V2. The question is find V1 and V2. Find V1 and V2. That's a given question. So that is a given question. So using nodal analysis. Using nodal analysis. So this is the question. So how do you solve this is you already are given this node and we'll take this as the reference node. So we need to find V1 and V2 values, apply. Before that, what we will do, we will take the current direction. This is already given as 1 ampere. So what are the different, this is the other branch. Let us call this as I1, this as I2, and to this branch there are 3. So this current is already considered and this is already 2 amperes. Let us consider this as R3. Now write this first node. In this you have one is 1 ampere coming out into the node coming into, and there is I1 that is going out, and there is I2 that is also going out with resistance 2 ohms. Now apply KCL at node 1. If you apply KCL at node 1, what is the equation? It is 1 incoming currents is equal to outgoing currents, I1 plus I2. Now you need to write the values of I1 and I2. What is I1? I1 is the current flowing from V1 to ground 0, that is 2 ohms resistor through 2 ohms. So I1 is equal to V1 minus 0 by 2. Similarly, what is I2 is equal to? It is the current flowing from V1 to V2. It is the current flowing from V1 to V2. So V1 minus V2 by what is the resistor value? 2. So substitute these values here. So 1 is equal to V1 minus 0, V1 by 2 plus V1 minus V2 by 2. Just simplify this. It is V1 by 2 plus V1 by 2 minus V2 by 2 is equal to 1. You can write it as you can write that as so V1 by 2 will become, it is V1 by 2 plus V1 by 2 minus V2 by 2 is equal to 1. Take LCM as take LCM of 2. So it is V1 plus V1, 2V1 minus V2 is equal to 1. This will give you further like this, 2V1 minus V2 is equal to 2. This is one equation. Now let us consider the second loop, second node. Let us consider Nagesh. Good evening, sir. Good evening, Nagesh. Welcome to Circuit Theory Crash Course. Let us consider the second node. What are the currents that are entering? I'll take the circuit to the next slide and we'll write KCL at node 2. KCL at node 2. We'll write KCL at node 2. Apply KCL at node 2. So when you apply KCL at node 2. So what are the currents that are entering here? I2 is entering, 2 amperes is also entering. So you can write I2 plus 2 is equal to I3. What is I2? I2 is the current flowing from V1 to V2. So let us draw that. This is from V1 to V2. There is current 2 amperes that is entering here. There is a resistor to the ground. So this resistor value is 1 ohm. This is 2 ohms. And the currents here are, this is I2, this is I3, this is 2. So what is I2 is equal to, I2 is the current flowing from V1 to V2. So V1 minus V2 by 2, and I3 is the current flowing from V2 to 0. I have considered it. So V2 to 0, it is V2 minus 0 by 1. Substitute these values here. So I2 is V1 minus V2 by 2 plus 2 is equal to I3. What is I3? I3 is the current that is going out. So we have written to this side. So it is V2 by 1. When you take this, V1 minus V2 LCM 2 2s are 4 is equal to, take 2 to the other side, it is 2V2. So V1, if you take V2 to the left side, it becomes minus 2V2. So it is 3V2 is equal to minus 4. So when you solve these two equations, there is another equation, 2V1 minus V2 is equal to 2. 2V1 minus V2 is equal to 2. This is the first equation of the node, first node equation. V1 minus V2 is equal to 2. Second node equation is Mahesh Reddy. Good evening, Mahesh. V1 minus 3V2 is equal to minus 4. Now let us try to solve these equations. In order to solve this, multiply this by 1 and multiply this by 2. So it is 2V1 minus V2 is equal to 2. This is 2V1 minus 6V2 is equal to minus 8. Now take minus sign. Minus, this will become plus, this because this is minus, this will become plus. Now if you cancel out, this is plus 6v2 minus v2 will be 5v2 plus 8 plus 2 is 10. So v2 is equal to 10 by 5 is 2 volts. When v2 is equal to, now let us take this to the next slide. So when you observe this, now what is the value of v2? We have got v2 is equal to 10 by 5 is equal to 2 volts. Now v2 is equal to 10 by 5 is equal to 2 volts. Now what is v1? So v1, let us consider one equation. Any one you can consider. Let us consider the first equation. 2v1 minus v2 is equal to 2. Substitute v2 value. 2v1 minus v2 is 2 is equal to 2. 2v1 is equal to 4. v1 is equal to 2 volts. So what is the value of, the question asked was find the value of v1 v2 using nodal analysis. So we have got v1 is equal to 2 volts and v2 is equal to 2 volts. So both voltages are same. So this is the final answer that you need to write. So this is nodal analysis. Now we'll see what is supernode analysis. So let us consider supernode analysis. What is a supernode? What is a supernode and what is supernode analysis? Let us consider this. Now what is a supernode is if a voltage source is connected between two nodes, adjacent nodes, then those two nodes combinedly are called as supernode. For example, let me give you a problem. Let us take, there is a question like this. Now there is a voltage source like this. Now if you consider this, let us take some values: 1 volt, 2 ohms, 3 ohms, 4 ohms, 5 ohms, 6 ohms and 5 volts. Now when you apply nodal analysis, nodal analysis is actually combination of KCL plus Ohm's law. But if you look at this, whenever you take these currents, you cannot write this current as V by R because there is a voltage source. So these two, in such case, these two nodes combinedly are called as, yeah, these two nodes combinedly are called as a super node. And what we will do is we will write, if this is voltage V1 and this is voltage V2, V1 is at higher potential, so we will write V1 minus V2 is equal to that voltage, and combinedly we will assume that there is no voltage source and write one equation to both the nodes combinedly. So that is what we will do in supernode analysis. So we will understand the supernode analysis with a problem. We will take up one problem and make you understand what is this super node analysis. So let us take one question. Yeah. So let us take a question. The question given is, I'm taking a question. Ajay Kumar CH, good evening Ajay Kumar. There is a current source with a resistor and a resistor again. So you have a circuit like this. I'm just taking this circuit. So this is the circuit. I'll just take the values also. This has 10 amperes, this has 3 ohms, this has 2 ohms, this has 1 ohm, and 20 volts plus minus. This is 5 ohms plus minus 10 volts, and this is 2 ohms. And the voltages given here are, this is V1, this is V2, and this is V3. Good evening, Ajay Kumar. Welcome to Circuit Theory Crash Course. Today we are dealing supermesh and supernode analysis. I'll mark the nodes with the other value. This is V2, this is V3. Now if you observe this is 20 volts. This is 2 ohms. Now let us consider this circuit. Now if you observe this circuit, there are 3 nodes, and also if you observe these, in between these 2 nodes there is a voltage source. Like I told you, because there is a voltage source between these two, we will consider these two nodes as a super node. This will become a super node. So let us first write about that super node. So this value is V2 and this is V3 plus minus 20 volts. So we can write it as V2 minus V3 is equal to 20. This is the first equation that you need to write. So there is a voltage source. Now second is apply KCL at, we are using nodal analysis. We have identified that this is a super node, and the question is, anything can be the question, like you can find, you will be asked to find voltages, or you will be asked to find any current in any of the branch or anything. So apply KCL at node 1, that is, this is V1. Now if you observe this, what is the current that is entering? Let us say this current is entering, this is leaving, and this is also leaving, and mark them. So this is 10 amperes already. So this is I1, this is I2. So I'll draw that once again. So this is 1, this. So you have a resistor of 3, and here there is 0 volts. You have a resistor which is connected to V2. This is V1, and this current. So this current is 10 amperes. Now I'm considering this current as I2, this current as I1. So when you apply KCL, what is KCL? Sum of the incoming currents is equal to sum of the outgoing currents. Thank you, Srinivas. Thank you. So algebraic sum of all the currents is equal to 0, or sum of currents entering is equal to sum of currents leaving. Thanks for neat color, clear color, full explanation. Thank you, yes sir. Thank you, Srinivas. So sum of the currents entering, 10 amperes is the current that is entering, and I1, I2 are the currents that are leaving. So you need to write what are I1 and I2. So 10 is equal to I1 plus I2. So hope you are clear with this. already. So I'll directly write 10 is equal to, what is I1 is the current from V1 to 0. So it is V1 minus 0 by 3 plus I2 is the current from V1 to V2. So V1 minus V2 by, what is this resistor value? It is 2 ohms. So 2, you'll get one equation, that is V1 by 3 plus V1 by 2 minus V2 by 2 is equal to 10. Now take this LCM 6. This will become 2V1 plus 2V1 minus 3V2, sorry, 3V1 minus 3V2 is equal to 10. Now let us consider this. So this is 2V1 plus 3V1 minus 3V2 is equal to 60. 6 is taken to the right side. So 5V1 minus 3V2 is equal to 60. So this is the one equation from applying KCL at node 1. So KCL at node 1. Now combinedly these two must be considered as one node, and then we need to take that. Let us draw this. Just take this part. I'll just take this part. We shall draw this. So let us take this and consider these two nodes as a single super node and write KCL equation. Write KCL equations. Now let us write this KCL equation. Now if you just redraw it, so this is V2. Assume that this and this V3 both are same. Now there is a resistor here. There is a resistor with a voltage to this ground, and there is one more resistor with 2 ohms. So let us consider the equation at super node. So this is V1. Let's write all the values. This is 2 ohms, 1 ohm, this is 10 volts, and this is 5 ohms, and this is 2 ohms. Now I'll write this directly. The equation will be at super node, it is V2 minus V1 by 2 plus V2 by 1, V2 minus V1 by 2, V2 by 1 plus V3 minus 10 by 5 plus V3 by 2 is equal to 0. So this is what you will write at super mesh. Apply KCL at super node. Sorry, it is super node. Now when you simplify this, you'll get LCM can be taken as 10. So it is 10. You'll write it as 5V2 minus 5V1 plus 10V2 plus 2V3 minus 20 plus 5V3 is equal to 0. So V1 is 5V1 minus plus 10V2 5V2 15V2 plus 5 plus 2 7V3 is equal to 20 can be taken to the other side. So this is V1 plus minus 5V1 plus 15V2 plus V3. If you look at the other equations, there is one equation V2 minus V3 is equal to 20. V2 minus V3 is equal to 20. And if you take the other equation, 5V1 minus 3V2 is equal to 5V1 minus 3V2 is equal to 60. Now let us consider this as equation 1, equation 2, equation 3. Now upon solving these equations, upon solving these equations, solving equations 1, 2 and 3. When you solve these equations 1, 2 and 3, you will get V1 is equal to 19.04, V2 is equal to 11.6, V3 is equal to minus 8.4 volts. So these are the node voltages. Now these are the node voltages. So this is how you'll get to find the node voltages in case of a super node analysis. Now let us say in this question, if there is some question like, let us take this question as find, instead of find V1, V2, V3, if there is find current in 5 ohm resistor, if this is the question. So if the question is, if the question is find node voltages using nodal analysis, if this is the question, the answer is V1 is equal to 19.04, V2 is equal to 11.6 volts, V3 is equal to minus 8.4 volts. So this is one of the important topics in supermesh supernode, which is very much helpful for your examinations. So if the question is find current in 5 ohm, current flowing through 5 ohm resistor, if that is the case, what is the current that we are, if there is some current, let us say this is I5, or if this is the current, so take that branch, let us consider that branch. There is a resistor with voltage 10 and V3 is, this is the 10 volts, and here you have a 0 and this is V3. Let us consider this current as I. Now what is I is equal to is, it is V3 minus 10 by 5, that is minus 8.4, V3 minus 10 by 5. So current through 5 ohm resistor will be minus 3.68 amperes. This is the answer. So we have seen today we have solved a problem on mesh analysis as well as on nodal analysis, and we have seen what is super mesh and a super node analysis. There are also other problems related to this super mesh super node analysis. Let us take one more problem and solve using super mesh and super node analysis. You must tell me whether this belongs to, now the question is, given question, I'm taking it from one of the textbooks. Find node voltages V1, V2, V3. Question is find node voltages V1, V2 and V3. I'll give you this as an problem. I'll just give you an idea how to solve this, and I want you to tell me the solution of this in tomorrow's class at least. And the circuit is given something like this. There is a resistor T network. This is the current source. I'll just give you an idea how to solve this. So this value is 0.5 ohms. This is 0.33 ohms. This is minus and plus 5 volts. This is 0.2 ohms and this is 1 ohm and 4 amperes. The voltage here is V1, voltage here is V2 and the voltage here is V3. Now the question is you are asked to find voltages V1, V2 and V3. Voltages V1, V2 and V3. Thank you Ajay Kumar. Very engaging, super. Thank you Ajay Kumar. You are asked to find V1, V2, V3. So you need to apply nodal analysis, which is, what is nodal analysis is, you need to apply KCL plus Ohm's law. You need to apply KCL and Ohm's law in order to find these voltages. But if you find this question, in this question you have a voltage source in between this minus and plus. You, in between V2 and V3, between these two nodes you have a voltage source. So these two nodes combinedly, these two nodes these two nodes combinedly will become, you can call these two as, combinedly you can call these two nodes as a super node. So you can call this as a super node and apply KCL to these two nodes, and this value is 5. First equation that you will write is V3 minus V2 is equal to 5, because this is at higher potential, this is at lower potential. You'll get one equation. Then you need to solve for the second one. Write KCL at node 1, apply KCL at node 1, you will get one equation again, the second one, and then you apply KCL to super node, you will get the third equation. And when you solve 1, 2 and 3, you will get the values of V1, V2, V3. I'll just give you the values of V1, V2, V3 and tell me whether you have got the same. Krishnachari, good evening, sir. Good evening, Krishnachari. Rajkumar, good evening. Welcome to Circuit Theory Crash Course. So this is 2.62 volts. This is 0.17 volt and V3 is 4.83 volts. Hope with the knowledge of supernode analysis that I have told you in today's session, you will be able to solve this problem. So with this, in this session, we have covered a problem on mesh analysis, one problem on mesh analysis, and also we have solved super mesh analysis, a problem on super mesh analysis. Then we have solved a problem on nodal analysis as well. Then we have taken up what is a super node and also solved one problem, and one is given as a test or assignment for you guys to solve this question using super node analysis. So what is a super mesh is, if you have a current source which is common to two loops, that becomes a super mesh. And if there is a voltage source connected between two different nodes, then that becomes a super node. So you need to consider two loops combinedly as, you need to consider these two. You'll get one current here, you'll have the other current here. You need to consider these two as two loops as a single super mesh, and here you need to consider these two nodes as one super node. The daily class starts at 6:45 p.m. Ishwar, the daily class starts at 6:45 to 7:45. And welcome to Circuit Theory Crash Course. So as I always tell you, we have India's number one study channels: Creatrix, Gate, Unacademy Gate CE, Unacademy Gate Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy Gate Questions, Electrical Junction, Unacademy Engineering Foundation, Unacademy Pathshala, and Unacademy Semester Exams. And you can also join us on this https://t.me Creatrix Gate Triply. Please do like and share and use my referral code for maximum discount, and subscribe to our channel and click on this bell icon to get notifications of my classes. Thank you all. Thank you for joining me for today's session. Okay, Ishwar, you can join at 6:45 p.m. tomorrow for the next session. I thank you all for joining me today.